We're continuing with section 6.6, example 2. We're on part D. Okay, so we have natural log of 3m plus 1 equals 2 times the natural log of m minus 3. Now, we said we're either going to solve this one of two ways. We want to write it as log equals log, and then we can say m equals n, or we want to write it as a single log and use the definition to rewrite it in exponential form and solve. So, notice we have a term here that isn't a log. So we can never end up with just log equals log because of that term. So there's our clue that we're going to need to use the definition and write it as a single log. So let's subtract the natural log of m minus 3 from both sides. So we get the natural log of 3m plus 1 minus the natural log of m minus 3 equals 2. Combine this into a single log. It's subtraction, so it will be a quotient with the first one on top and the second one on bottom. And now we'll use the definition to change it to an exponential. Now this one's a little interesting because what's the base? It's e. E to the second power is equal to 3m plus 1 over m minus 3. Okay, this is a number. It's not a variable, but it's an irrational number. We need to solve for m. So how will we do that? Well, multiply both sides by m minus 1 to get it out of the denominator, right? M minus 3, sorry. m minus 3. So we get e squared times m minus 3 equals 3m plus 1. Distribute, we get e squared m minus 3e squared equals 3m plus 1. So if I want to get m by itself, I need all the m terms on one side. I'm going to put them on the left, and all the constants on the right. This is just a number, right? That's not a variable. That's a number. So I'm going to move the 3e squared to the right, and I'm going to subtract 3m so that all the m terms are on the left. So I have e squared times m minus 3 times m equals 1 plus 3e to the second. I want m by itself. How can I get m? I just want this to be m equals. How can I start getting m by itself? I can't really subtract this without finding out what that is in a rational form, and now I've got decimals and I'm rounding, and I don't want to do that. So I'll factor the m out. I hope you were thinking that. And now to get m by itself, I'll divide both sides by this expression here in the parentheses. So m is equal to 1 plus 3e to the second divided by e to the second minus 3. This is my exact form for that answer. 1 plus 3e squared over e squared minus 3. Now, I would need to find out what that is in order to know if it's in my domain. But let's look back here. So we know that 3m plus 1 has to be greater than 0. So 3m has to be greater than negative 1, and m has to be greater than negative 1/3. And we know that m minus 3 has to be greater than 0, so m has to be greater than 3. So which one of these is controls the whole domain for this? Well, the greater than 3, right? So for it to be both of them, here's negative 1/3, here's 3. One of them says you have to be greater than negative 1/3. The other one says you have to be greater than 3. So greater than 3 is the one that works for both of these. So this is what guides it. So the domain, I know, is 3 to infinity, right? So now if I knew what that number is, I could say whether or not it's in the domain. So actually calculating that is necessary. So e on your calculator, raise e to the second power, multiply by 3, add 1, that's your numerator, raise e to the second power, subtract 3, that's your denominator, and you should get something like 5.278 approximately. Now I know whether or not it's in the domain. Is it in our domain? Yes. So now I'm comfortable putting it in my curly brackets and saying, yes, this is the answer. Because I know approximately what it is, and I know that number is definitely above 3. So did I have to do this analysis? I could have just gotten that number like I did before and said, okay, something a little bigger than 5 is going to be fine here. Something a little bigger than 5 is going to be fine here. We'll keep it, right? All right, let's look at part E. We have 2 times the log base 9 of x equals negative log base 9 of 81. So we don't have any terms that aren't log base 9. So we can write log equals log. So we're almost there. The only problem is that 2. So I'll rewrite this as log base 9 of x squared equals, and this negative 1, right? That's the same thing as a negative 1. Log base 9 of 81 to the negative 1. Okay? So I've taken my factors here and made them powers. So if log base 9 of x squared equals log base 9 of 81 to the negative 1, then x squared has to equal 81 to the negative 1. And what's 81 to the negative 1? That's 1 over 81 to the positive 1. And let's take the square root of x squared plus or minus the square root of 1 over 81. And x equals plus or minus 1/9. Now, think of our domain. We have the x here. Can we put in negative 1/9? No, we cannot. We can put in positive 1/9 though. So that is our solution set.